When airflow is forced to change direction, the disrupted air is turbulent. Turbulence is noisy and wastes energy. In the latest generation of Dyson fans, turbulence is minimized, ensuring they're quieter and more efficient than their predecessors. This begins with the intake holes, carefully arranged so air is drawn evenly into the machine. Motor noise is captured and dissipated by a Helmholtz cavity, and any vibration is isolated by an acoustically engineered motor casing. The fins of the impeller are asymmetric, so each harmonizes with the others, and they have a scalloped trailing edge to further improve acoustics. An aerodynamic diffuser separates the airflow into controlled parts for efficiency. Air is then channeled equally into the two sides of the loop. It has a larger volume at the bottom, which allows air to enter with less turbulence, reducing noise. As pressure in the loop builds, air is forced out through the aperture at a high constant velocity. As the airflow exits, it clings to the airfoil-shaped ramp, generating maximum velocity and projection. Surrounding air is then drawn in from around the loop, amplifying the volume of air projected. This is how air multiplier technology projects smooth, powerful, high-velocity airflow. Powerful airflow, no blades. The Dyson 360i robot is powered by the high-speed Dyson digital motor. It's small and light, yet delivers higher suction than any other robot vacuum. A unique 360-degree vision system sees all the way around itself at once, selecting reference points to track and triangulate its position so it knows where it is, where it's been, and where it is yet to clean, systematically cleaning your home in 3-meter grids. Patented radial root cyclone technology generates powerful centrifugal forces to fling dust out of the air and into the bin. The robot's cleaner head spans the full width of the machine. Carbon fiber filaments remove fine dust from hard floors, and stiff nylon bristles remove ground-in dirt from carpets. Continuous tank tracks climb over obstacles and maintain speed and direction, ensuring it stays on course. And the Dyson Link app allows you to start, pause, and schedule your cleans, as well as monitor and update the Dyson 360i robot vacuum. The Dyson 360i robot, the most powerful suction of any robot vacuum.
This is a new product from Dyson. It's a Dyson hairdryer. The key to the technology is a completely new type of motor. But first, we had to study the science of hair to discover what made hair glossy and shiny, draws in air from the back through here, just like we do on our air multiplier fans and heaters. We have a glass bead thermistor at the front here, and that's measuring the temperature of the air that's coming out of the hairdryer 30 times a second. So this is vitally important in stopping too much heat getting onto the hair. When you use a hairdryer, you're holding your arm up here all the time. By putting the weight in the right place, and we put it in the handle rather than in the top of the hairdryer where it normally is. This is a conventional hairdryer motor, and this is the Dyson motor. The axial blade fan runs at 110,000 RPM. This type of production is absolutely essential to produce a motor that runs at 110,000 RPM. The attachments fit on magnetically, and they rotate, so you can get it to exactly the right angle. And they're double-skinned, so that they're cool to the touch. None of you will ever use the hairdryer like this. We quite understand that. But here he is. He's 120 kilos. Please don't do this at home. This is only in our testing laboratories.
building we're in originally, in the Victorian times, was used for designing mechanical and electrical lifts for buildings, and it's quite apt that, in fact, we've brought that back to life in some way, that we're engineers and we're designing lights. The process of how we work in this building is to look at and analyse lighting and find ways to dramatically improve them with efficiency, or with engineering and innovation. We don't design to make things look good. We don't use that as a starting point. Our starting point is to investigate and experiment. I also really enjoy manufacturing. I love, seeing manufacturing processes, how things are made. It's what makes you a better designer. I have workshops downstairs and I've got a machine shop downstairs, so within this premises in London we're able to design on computers, make things, prototype things and test things all in one space. It's a very interesting journey, and there's always so much to learn. I spent 6 months looking at task lights and the problems with them, and the big problems that stood out was the lack of direction of light, and the arm of the light was positioned by springs and pivots, and those wear out over time. So wherever you position your light, it would drop. So we incorporated a completely new mechanism which was inspired by drawing boards and elevator lifts. The light moves up and down and rotates and moves in and out. And so we've rethought about the positioning mechanism for a light, so that where you position it, it stays where it is. And we've also hidden the LEDs up inside sort of conical cones, and that has two effects. It gives us a very even spread of light with no need for diffusers, so we have high efficiency on light output. So we sort of rethought about all the characteristics and function of a desk light and innovated on every single element of that. And that really sums up what we do here. My greatest innovation to date is probably the ability to cool LEDs, and it's something that's completely critical to the LED lighting market. The overall life of the LED is reduced if they're not thermally managed correctly. I'm not interested in selling lights that last for 7 years. I want to sell lights that last for 40 years. And I respect the technology and I want to do the best thing by it. So I think that the performance of cooling in the products that we've done is outstanding, and I hope will lead as a role model to other lighting manufacturers incorporating LEDs. If this was solid copper, it would take about 3 minutes for the heat to actually go from this end to my fingers. But now when I rotate it in the hot water, it's already there. It's very, very hot. And then I rotate it in cold water, stir it in the cold water, and it's much, much cooler instantly. The speed that heat transferred up that heat back to my fingers is the same speed that the heat is being drawn away from the LEDs. So that's the principle, that's the technology we've applied into our products. It hasn't been a hindrance going down the same path as my father or inventing. In fact, I must say I think I find it easier to invent than replicate. I think if you've got good ideas, which I'm fortunate to have, then it's in some ways easier to start from scratch doing something no one else has done than it is to try and improve on something that someone else has done or might have done well. I guess the one thing that I have potentially learned from my father is don't give up, and that it's grueling, it's not an easy process and it's hard work. We don't make our job easy, but the end result is much more interesting.